Alright, so I'm going to do a little tutorial for you on modeling threads and heated inserts. So there are two methods of essentially screwing 3D prints together using a couple of different methods. So modeling threads is a fusion process, and heated inserts is a bit more simple but requires a bit more manual handling after you've printed your items. So for heated inserts, you're kind of looking at this sort of thing. Essentially what we'll be doing is like modeling holes into two separate bodies that you want to screw together, and you essentially melt this little brass fitting here into your 3D prints. You can see down here it's probably more ideal to add extra walls to make it a bit stronger in that kind of melting process. That's a kind of engineering drawing here of what it looks like. What it allows you to do is to put metric screws into your 3D prints. So there's an example there of what it looks like. Yeah, it just depends on the application, how you want to use it, but it can be a really, really handy thing. And I'll show you some examples of this in class and around the workshop as well. So I'm going to start with how to model heated inserts. So without further ado, we'll get into it. So I'm going to start with a blank model, and I'll go through and pause this if I need to, but I'll do the best example that I can think of at the moment. Often, if you're designing something really big that only fits, it won't fit on a single 3D printing platform, you'll need to break up your design into different parts. So our Bambu P1S printers, they have a max volume of about 250 millimeters by 250 by 250. So if you're designing something that's bigger than that, and that's quite common, you'll need to be clever in how you manufacture your work. So what I'll do here is give you that example. I won't go to the full 250 size, but I guess I could do a 200 piece. So 200 and 200. And this will just essentially be a 3 millimeter block like this. But if I wanted to screw this in really securely to another 300 millimeter block, I'll show you what I could do. So what I'll do is I'll turn this into a component after I finish modeling it. So from here, I'll just go create components from bodies. That'll be component 1. Unground that, and then I can start working on this individually. So the reason I'm making a component is so after I make the original, this will essentially be a modular design. So I can copy out that module and put in as many copies of it as I need to build the thing that I want. In this case, it's just a flat panel that you can screw together. So here, I'll just go in and add a sketch to the top, and I'll do an offset of the outside of -3, just so I build a little wall there. I could make it a bit stronger if need be. So 4 millimeters I think I've done there. And I will extrude that up by 4 millimeters as well, maybe a bit higher, 5. And then what I'm going to do here is just put in a series of holes. So I'll put one in the middle and then one towards either side. So I'll go up here. The holes themselves will be about 4 millimeters. Generally, the heated inserts we use are about 5 millimeters across. So I'll make a hole of 4 millimeters there. Then I'll do another hole over here. It's possible I'll have to move these up. Yep, I'll just move these up a little bit. They're a little bit low. So I'll actually just do all of this and then I'll move the whole thing up. The issue is that when I go from here, you can see that they're hitting that base there. So you need to be kind of aware of where you're placing your features. So I'll go here and I'll mirror that over the origin line here. Cool. Okay. And then I'll move these up. That should be enough. Okay, so I'll go finish on that sketch, and then I will just punch a hole through this little part that I've got here. So I've got those 3 bits there, and I'll extrude them through to the other side here. Perfect. And then what I'll do is around all sides, I'll just copy that. So I'll do a circular pattern of that feature. So I've got that feature selected, and the axis will be around here. And I want 4 copies, so it goes equally around the 4 sides. This is why it's really important to model around the origin of your components, so you can do things like circular patterns and rotations and stuff like that. So I'm pretty happy with that. No. So adjust, optimize, see if that works. There we go. All right, so now I've got holes all around the side. I know they're all in the same position. So all I need to do now is essentially component modeling. So what I'll do here is select that component, and I'll do hotkey M, but I can also go move up here. And I'm just going to do a simple point-to-point move. But you've got to make sure that you have create copy selected. So I'll go, I want to move this point and make a new copy over here. So that's my origin point, and I want that point to be kind of lined up on here. I'll just go like that. So the reason this is a component is anything that I change to the original. So say if I get my sizing wrong with these holes, I can just change that one original component and it'll be reflected in all my others. So with heated inserts, what I would do here is actually, once this is 3D printed, I would melt a heated insert into one of these sides, not both, just one. And then I could screw in a metric screw from this side into the other. Yeah, there might be a few little issues with getting a screw in under here and things like that, but that's a matter for kind of fine tuning and experimentation. Another thing I could do is probably raise that wall up another millimeter or so. So maybe here. So I've set that to 5 mils. I could probably set that to 6 and raise that all up. And then when that's done, you'll notice that that's also reflected in my other components. And then this one here, if I change the position of this SketchUp as well, so I go back to this stage, I can fully edit that component and move that SketchUp another millimeter. Give myself a bit more space. All right, so I've got my parts here. Now, I'm just going to insert like a pre-done component of a heated insert. You don't need to do this. If you just want to design like this, leave those holes there, you'll be able to put your heated inserts in. But it pretty much looks like this. I'll turn off one component and I'll insert derive. So I've modeled a heated insert for this demonstration. Okay, it needs me to save it, and then this is the derive function. So I've got this saved in my fasteners folder, heat set inserts, and M3 heat set inserts, what I'm going to use. That's the model of it there. And I'm just going to select that body. You just click on it and go OK. And what that does is it drags it out of that original place and moves it into your design. So you can see it here kind of stuck in the middle. That's there as a body. And you see this little arrow here. That's linked to the original design. So any changes I make here to edit that actual component will be linked to the original. But you can break that link and do whatever you want with this model. So you go there. So I'm going to move this into position. So I'm going to go here. And just I'll do some kind of broad moves first. I'll move it outside. Get my rotation set. So here, rotate that by 90. And then move this kind of into the right position, and then I could do point-to-point moves if I needed to. But that looks like it's actually centered, which is really good. So, and then all I would do here is just put that in. Like that. If you need to do more fine movements, you just zoom in a little bit more, like that. And that's what a heat set insert looks like when it's actually in. So that's melted into position. And then what you would do is get your other component, and all you really need to do here is put in a metric screw. That'll screw through, pull them together really tight, and that's a really stable, solid join for you and your work. So that's pretty much how you do it. I will dem that in class as well. But the next thing that we're going to do is how to actually make a thread. So I'll start a new design here, and I'll do just something really basic. So I'll go here and start a new sketch. To make a thread, all you really need to do is start with a cylinder. So I'll make that 10 millimeters. Probably 8 millimeters is probably more of a common metric sizing. So I'll go there, I'll finish that sketch, and then you just extrude it like you would any other object. It can help to go symmetrically over the origin, just for good practice in design. I'll make this a 20 mil thread. And then on the top here, you could do like a bolt design. I often model in wing nuts, and I can show you an example of that in another design. But for this one, all I'll do here is just put a hexagon on top. So I'll go create, where is it, polygon. I want to make a 6-sided shape. And that will be it's 12 across, good. So finish sketch. Select both of those areas and extrude those up by like 5 mil or so. And there's a kind of rudimentary like bolt shape. So now for the threads. When you want to do this, it's in create, and you go down to this one here, thread, and it'll kind of select any cylindrical surface for you. So it'll also detect the size and put in a metric profile for your threads. The reason this is a really good tool is because you can 3D print these and they work really, really nicely. These ISO metric profiles do print nicely because of this angled pattern. You could put this straight into the printer and it will print fine. So here you can select how fine you want your thread to be. If you are 3D printing it, the larger the space between threads, the better. Yeah, and that's a right-hand thread. Often you can also do an internal thread as well. So if I had another body over here, do a sketch off to the right, and go here, and turn that into a solid. You can also go in and sketch onto that and add an 8 millimeter hole to that as well. And that will allow you to do a internal thread. But there's another way you can do it as well, which I find a bit easier. So you put a hole through there, and then you can go back to threads, go there. You always want to select modeled. Okay, so if it comes out looking like this, a bit weird and two-dimensional, always select modeled threads so you can actually, manipulate them. So yeah, that's a way of doing an internal thread. Now, if you're 3D printing these, there's two main issues that you're going to come up against. One is if you flip this around and print it like this, the print layers will go this way. If that bolt goes under any kind of stress, it's going to break quite easily. So the main technique that I use to get around that problem is you actually cut the bolt in half this way, and you print it flat against that cut surface. So I'll show you what I mean. So with this body here, you go to split body, and the splitting tool can just be the origin plane. So here, and I'm just going to go OK. And you'll notice that that'll put, now I've got 3 bodies, so body 1, and body 3, the 2 halves of the same thing. And when you go to print it, you would put that kind of flat down. I'll start our Bamboo Studio in the background, so we can do that. Another thing to look at is when you do a thread, sometimes it can be a little bit hard to get this part kind of into your thread. Also, that's very thin there and can be a quality issue when you're designing threads as well. So one little trick that I do here, I think I learned it off Instagram somewhere, is you use your timeline. So you go all the way back to when you've made the thread, and you go one step before, and you put a chamfer on your thread. So I'll go 1.5 millimeters. So you put the chamfer on just to make it a bit easier to screw into the hole that you're, that you're modeling. So maybe 1 millimeter is a bit better. Okay, so I've gone before that thread was made, and I've added a little chamfer. And what that'll do here is kind of make that a bit easier to screw in, but still I need this opening to come up. So I don't know why it does this, but when you drag the thread now before the chamfer, it just makes it a bit more friendly for printing and fitting. Okay, so that's one trick I always do. The other one is splitting the body. Okay, and then there's one other essential thing that you need to do as well. So if I was to take this M8 bolt and fit it into this hole after 3D printing, it wouldn't fit. Why? Because 3D printers tend to overprint from their boundaries just a little bit. So even like 0.1 or 0.2 of a millimeter won't really print what you want. So putting this in, it'll maybe go in a little bit, but then it just gets stuck. So what do we do? To fix this problem, and it's just specific to 3D printing, you use this little tool here, the press pull tab. And what you want to do is add a bit of slack to all of these internal surfaces here. So you go press pull, and you want to make sure that all of these areas, so I'm holding down control as you can see, you want to make sure all of these areas, or these surfaces, sorry, are selected, top and bottom. Okay, these are the same threads, so that all looks good to me. One other little thing here, usually it will pick up all the surfaces, and that's fine. Then what I do here is I'll put in, I'll push out that area by 0.1 to 0.2 millimeters. So if I go negative 0.2, you'll see it pushes out all of those surfaces and gives them a little bit more slack. So at 0.2, it'll be nice and easy to screw in, and it'll still hold really well as well. So you can see here the size difference between doing that push-pull function. So you need to do that in order to make your threads work. Another thing you might want to do is, rather than having to thread the inside and the outside, you can just make a block and run a cut function. So I'll do another sketch over here. I'll do another block over here. I'll extrude that like that. And if you want to make this go through here and not have to go through the whole threading process, what you can do is select the bodies that you want to move. It's probably a bit easier to do before you've done the split body. So I can go back and just suppress or delete that. Well, I can unsuppress that later. Then what you would do is take this body and you want to move it. So here, I'm going to move it 180 degrees, move it so it's over that block there, and you pretty much just want to drag it directly in to that block. It doesn't matter how far through it is. You could do it here, or here, it doesn't really matter, as long as it goes all the way through, if that's what you want it to do. You can also make it go partially through as well. But essentially what you want to do here is put that movement in place, and then you run a cut combine. So you go to the combine tool, and you cut this body using this body as a tool for cutting. So that's your target body there. Then you go tool bodies, which is the bolt here. And under operation, you have join, cut, and intersect. I usually use join or cut. This can be useful if you've made like a whole bunch of different bodies that you didn't mean to. You can kind of combine all those back together. But cut's really handy because you can, obviously cut negative spaces out of things. I use it quite a lot. When you go here and you select cut, the thing that's cutting will turn red, and the thing that you're cutting out of will turn blue. One thing you want to do here is make sure you go keep tools. If you do want to keep that cutting tool there, I obviously want to 3D print the bolt when I'm done after all this. So I'm going to go OK. All right, and then when I turn off the view of this, you'll see that that's cut my perfect thread exactly the same way that this was cut as well. But I still have to go in and select all those surfaces like I did before, and make sure that I do my press pull of negative 0.2, 0.15 would work fine as well. So it does exactly the same thing. The bolt will fit really nicely. Just make sure that I've actually got all of my surfaces selected. Yep. And there we go. I'll go okay there. So those two negative threads or outer threads will fit this bolt quite nicely. So I'll move this bolt back into position. Move it back out here. Go okay. If I unsuppress this, then it should go back through. Or maybe it won't. Oh no, there it is. So when you want to 3D print all of this, I'm going to go save this. And to get all of these 3D objects out as separate STLs, I'll right click on the name of my model, the very top of my model tree, and go Save as Mesh. And in this menu, under Structure, I'll change one file to one body per file. Okay. And make sure I save this to my downloads. And what this will do is name all of these bits separately. So in this case, it'll be body 1 to 4. And then when you go through to 3D print, you'll go to Bamboo Studio and add in all of your things. So download, you'll see threads down, body 1, 2, 3, and 4. I'm just going to hit the top one, hold down Shift, and go to the bottom. Go open. You can load these as one object with separate parts, that's fine, but I usually go no, just so I can have a bit more freedom over these. It's a bit easier for me. Then you want to arrange them so they're all separate, and you'll see what I mean here. So to print this properly, you can leave those as is, but these bits of the thread here, you would select that part and go lay on face and lay that flat, and do the same with this one as well, lay that flat and then rearrange them. Okay, so one thing you might also want to do if you're printing a lot of these threads, you'll need to keep track of which side this is, because this object and this object are different. So you might want to go in and put a little X on one or a little 0 on the other, or a number 1 and a number 2 here. Yeah, that's pretty much it. So you go through, slice that. If you're happy with the quality there, that's fine. You can, to make these come out extra good, you can go through and do a finer. So set it to fine. Another thing that you can do to make these print out really nicely is in your settings when you go to prepare. For these objects in particular, if you go to variable layer height, what this will do is it'll change the thickness of the layers that you're printing to make them print really, really smoothly. So if you change it more towards quality rather than speed and hit adaptive, you'll see here. So it's going to go really thick layers at the start and then really thin layers where it's getting to the more finely detailed parts of the thread. And then for this part here, it's going to go thick layers again. But it's a really good compromise between time and quality. Yeah, I use it quite a lot. So I'd go here and just hit adaptive to apply it there as well. And then when you slice it, you'll notice the difference in the thickness of layers for those particular objects. So these are all standard, but here, when you zoom in, you really notice that these layers are thicker and the ones on top are thinner, and that will lead to really nice quality threads there for you as well. That's pretty much it. Yeah, to go and print this, you know exactly what to do. You go and export plate slice file, or save this project in your Google Drive, and that's pretty much it. So happy threading, everyone. Hope that gave you everything you needed to do.